Good morning, my dear students. I, Annu, welcome you all to this online class of chemistry, Chapter 5 Language of Chemistry. It is a revision video, my dear students, since we have already covered the chapter in the offline classes. So, in this video, I am going to share some of the important points that are with respect to the chapter that has already been taught to you in the class. So let us begin. In the first slide that we are going to see, let us see some of the important points. The first very important point is a symbol is an abbreviation of the name of an element. A symbol abbreviation means it is a short form of the name of an element. It consists of one or two letters of the English name of the element, right? We have already learned in the chapter that a symbol, it represents basically either it is taken as a first letter or the first two letters of any of the element for which we are writing the symbol. It might also be derived, an element may also derive the symbol from the Latin name of that particular element. For example, if we see here, the symbol of aluminium is Al, right? The symbol of aluminium is Al. Now here, my dear students, you can see that this Al, right? So Al here, it is what? It is the first two letters, right? They are the first two letters. Okay, so the first two letters are taken. It can be one letter, it can be two letter, or even it can also be the Latin name of any of the element. Then moving further, we have the next point, that is the symbol represents the element and one atom of it. So here Al is a symbol of aluminium. So it also represents one atom of aluminium. Either I can say that it is representing aluminium or it represents one atom of aluminium. A formula represents the molecule of an element or a compound. While I talk of an element, you know that it is single element, right? And compound, it is made from two or more elements, right? So a compound is made from two or more elements. So a chemical formula either can represent a molecule of an element or it can even represent the molecule of a compound, right? Suppose if I talk of H2O, so H2O, it is a compound, right? It is a chemical formula for water, right? So it represents two atoms of hydrogen in combination with one atom of oxygen to form one molecule of water, right? So a formula can even used to represent a molecule of an element or a compound, a formula or a chemical formula. For example, here you can see that is CuO. Now CuO, my dear students, you know that it is made from CuO, it is made from copper, and it is made from, this is copper and this is oxygen, right? So the compound is copper oxide, right? The compound is copper oxide that has been formed. And why it is written 1 here, right? Because 1 is written so that the copper is an element with a variable valency. It is representing copper 1 oxide. So it's a compound. I hope it is clear to everyone. So this is, I think, clear to everyone that a chemical formula, it is used to represent the molecule of an element or a compound. Like here, it's a compound that is copper oxide. Now moving further, we have the next point is The combining capacity of an element with the other element is called the valency of that element. The combining capacity of an element with the other element is also called the valency. It is also given by number of hydrogen atoms that one atom of the element combines with or displaces from a compound. Different elements may have different valency. An element can have a valency in the range from 1 to 4, right? So the valency of any of the element increases from 1 to 4 and gradually it reaches to 0. Again, it goes from 1 to 4 and finally falls from 4 to 1. It is going to end at 0, right? So elements with same valencies are placed under same column in the periodic table. So all those elements which have same valency, they are placed under same column in the periodic table. Moving further, we have next is the next point here, my dear students. It is the formula of a binary compound. What is this? The formula of the binary compound. Let me clear this up that I've already explained in the next previous slide. See, the formula of a binary compound can be obtained by transposing the valencies of the element. Now, what is a binary compound? A compound that is formed by only two elements, that is termed as a binary compound. So how can we obtain the formula of a binary compound? It can be obtained by transposing. Transposing means exchanging the valencies of those two elements. Suppose we have an element A that has valency Y and we have an element B that has valency X. Now we have to form these are the two elements which are forming this binary compound. So their valencies would be exchanged, right? So this valency X would be going to A and the valency of A would be going to B, right? So what is the formula that is obtained? AX BY. AX BY, because the valencies have been exchanged or transposed, and it leads to the formation of that binary compound. The valency of a radical is the same as the charge on it without the sign. Now, what is a radical? I've already explained. A radical is an atom with a charge, or it can also be said as the group of atoms with a charge on it, right? Or the group of atoms behaving as a single atom with a charge on it. So this Mg2 plus here, it's a radical. Why? Because it's an element with a charge on it. So this is a radical. So what is going to be the valency of this radical? It is going to be the same number with no sign, that is 2, right? So this is a radical. The valency of this is going to be same number with no sign. That is why the valency of magnesium here, it is 2. Now, in a compound containing radicals, the positive and the negative radicals must be present in such numbers so as to cancel the opposite charges. Now, what this point is, suppose this is a compound that is sodium hydroxide. It is formed from two radicals, that is Na plus and OH minus. So this radical, you might be wondering, my dear students, this radical, it has the valency +1, right? The valency is only 1. And here, why it is only 1? Because it is having only one positive charge. And here the valency of OH is, the charge is negative, right? That is -1. So both +1 is going to cancel with -1 and both of them are going to form the compound that is sodium hydroxide. So in a compound that is already having the radicals, they should have the radicals in such a manner that the negative charge should cancel with the positive charge and the relevant compound is formed. So this was about the compound containing radicals. Moving further, we have the next important point. A chemical reaction is represented by a chemical equation. Now, what is the chemical reaction? Chemical reaction can also be termed as a chemical change, like those changes which are permanent in nature, which are generally irreversible. So that are also the chemical reaction or chemical change. So a chemical reaction is represented by a chemical equation, right? So here, my dear students, you can able to see, let me clear this one also. Now, my dear students, here you can able to see that carbon, when burnt in sufficient supply of air, it forms carbon dioxide. So it's a chemical reaction, right? So this chemical reaction I can represent with the help of a chemical equation. This is a chemical equation, that is carbon plus oxygen burning in the presence of oxygen will give carbon dioxide. So this is a relevant chemical equation in order to represent this chemical reaction. Now, this was about chemical equation. Now let us learn about balanced chemical equation. A chemical equation is said to be balanced by making an atom count of each element on both the sides of the equation and placing the proper coefficients. What do you mean by that? In this equation, we can see that there are reactants, carbon and oxygen are reactants, and what is the product? That is carbon dioxide. This is the product that is formed. So here, which are the elements which are present? Carbon and oxygen. So the number of atoms of carbon on reactant side should be equal to the number of atoms of the carbon on the product side. Similarly, the number of atoms of oxygen on the reactant side should be equal to the number of atoms of oxygen on the product side. Then only I can say that the given chemical equation is a balanced chemical equation. So we should check first the number of the elements which are present in the entire reaction, then the atom of each element either on the reactant or the product side. On both the sides, the number of atom of each element should be equal to each other. Then only I can say that the equation is a balanced chemical equation. Now, a chemical equation can be made more informative by mentioning the state of each reactant and product. What does that mean? If I want to convey more information to this equation, I can mention the state of each reactant or the product that is formed, whether it is solid, liquid, gas, or in aqueous state. So we can mention the state of each of the reactant and product. Plus, we can, in the next presentation, you would be seeing that even we can mention the conditions of the reaction. What are the conditions? Suppose that the reaction is occurring at high temperature, or is it occurring at low pressure, or it is occurring in the presence of electric spark or lightning. So those are the conditions of the reaction. Or if we are using any of the catalyst for the reaction, what is a catalyst? A catalyst is a substance which speeds up the rate of reaction, but itself remains unchanged, right? So even if you can mention that those conditions, it is going to convey more information to your chemical equation. Right? Then after that, we can even mention the color and the name of any substance that is either the reactants or the products. Even we can mention that in order to convey more information to our chemical equation. Now, these were the important points that were basically covering the entire chapter. I hope it might be clear to everyone. Now, let us discuss some objective questions that are the part of your chapter, and we have already discussed. First is multiple choice questions. First answer is which of the following symbol is not derived from the Latin name of the element? So the answer is Cr, that stands for chromium. Which of the following symbol is derived from the Latin name of the element? That is Ag, silver, right? So it is the symbol of silver is derived from the Latin name, right? Then third, which element among the ones appearing below is pentavalent? That is PCl 5. Then what is the valency of Mg in Mg3N2? The valency is 2. What is the value of X in the following equation? So answer again is 2. And the last one, we have to tell which of the following is not a balanced chemical equation. So you would be able to see that this equation is not balanced, and because in this the number of atoms of the elements are not same on the reactant and product side, that is why the equation is not balanced. Now moving further, we have fill up. In fill in the blanks, first is nitrogen is trivalent in ALN. Then one sulfate radical will take up two sodium radical to form sodium sulfate. Then again, we have to fill the number of atoms of the equation. Answer is 2 and 2. For the fourth one, it is also 2 and 2. And for the fifth one, it is also 2. Coming on to true and false, we have ozone is a triatomic gas. That is true. And atomicity of sulfur is 4. False. One di-positive radical will require only one di-negative radical to form a compound. That is true. A noble gas element is monatomic as well as monovalent. It is false. A substance in solution is indicated in a chemical equation by symbol S. That is again false. Is that clear to everyone? I hope the exercises might be clear to everyone. Okay, you can once again go through your answers. Now let us discuss some of the short questions. By going through this revision video, I hope you might be able to answer these questions. What does the symbol of an element mean? I've already told you in the first presentation that it represents one atom of an element, or it is an abbreviation of the name of an element. How are the symbols of carbon, chlorine, chromium, and cobalt distinguished from each other? Then in this, we have to write the symbols of these elements. Carbon stands for capital C, chlorine, capital C small l, chromium, capital C small r, cobalt, capital C small o. And name 3 monoatomic gases with the symbols helium, neon, and argon. The symbols are already given in the book. From which words have been derived the symbols of sodium, potassium, iron, and copper? So you have to write the words from where these elements are deriving their symbols. After this, we have derived the formulae for copper second chloride and copper second sulfate. What is the formula of aluminium sulfate? Name the compounds FeO and Fe2O3. What do you mean by a balanced chemical equation? How many molecules of hydrogen chloride will be formed when a molecule of hydrogen reacts with one of chlorine? So all these questions you would be able to solve by just going through this revision video, and even we have already done in the offline class. So thank you, my dear students, for watching this video, and please try to do all the questions. Even there are more questions that have been left out from the chapter in this video, so you can even try for those questions and even for the long answers. All the answers are already discussed and marked by you and even written in the copy by you. So those who have not completed, you can go through this revision video and complete the same. Thank you, my dear students, for watching this video. Stay safe, stay home.